Okay, so we need to figure out how to calculate beta. And one common way that we do this is through something called linear regression, which I hope you're familiar with from your statistics class. And so what we need in order to be able to do this linear regression is we need returns for the market and we need returns for the stock in question. And so what I've got here is some data. The columns that say GE and SPY were downloaded from Yahoo Finance. You can download historical data. And so GE, that's just General Electric, so that's the share price for every day in 2007 and the last day in 2006. Now why the last day in 2006? You need that in order to be able to figure out the first return of the year. And I've done the same thing for SPY. Now what is SPY? Well, it is an exchange-traded fund that is designed to mimic the S&P 500. And the S&P 500, we said, was a proxy for the market portfolio. And so we're using a proxy for a proxy here. And that's going to be our market return. I also have RF, which is the risk-free rate. And I got that from the St. Louis Federal Reserve's website. Okay, now the next step, of course, is to figure the return for each of these stock prices. And so, if I click on the cell here, you'll see that all I've done is taken today's price minus yesterday's price and divide by yesterday's price. And I do the same thing over here for the S&P 500. That's how we get our return. So that's pretty simple. Let's see, now think about that security market line equation. It says the expected return on the security is equal to the risk-free rate plus beta times the market risk premium. And so I'm going to make one little change. I'm going to subtract the risk-free rate from both sides. So on the left-hand side, I'm going to have the expected return on the security minus the risk-free rate, which is also known as the market risk premium, it's the risk premium for the security. And over on the right-hand side, that just leaves us with beta multiplied by the expected return on the market minus the risk-free rate, which is the market risk premium. Okay, now, by doing that, we get rid of our y-intercept. Risk-free rate was our y-intercept. And so when we do this regression, the intercept should be 0 or really, really close to it. Now, linear regression, if you've ever done it by hand, is extraordinarily painful. And so we're going to go about this a different way. We're going to let Excel do the work for us. Now, Excel comes out of the box like this. If you go to the Data tab, you'll see there's nothing up here about regression or anything like that. And so what we need to do is load an add-in so that your Excel can do this. And here's how we do that. Go to File, then we go to Options, and we will go to Add-ins. Now don't be fooled, it won't work to click on stuff up here. You have to go down here where it says Manage Excel Add-ins, and I hit Go. And now you want to click Analysis Toolpak. VBA is a programming language. I don't know what difference it makes. So I'm just going to click Analysis Toolpak and hit OK. Now notice now that we have data analysis up here on our toolbar. I'm just going to go ahead and click that. And I'm going to go through here. There's all sorts of neat stuff that you can play with. Correlation, covariance. But we're going to do regression and hit OK. Now I want to put in the Y range. Remember, Y is expected return on the security minus the risk-free rate. And so all I'm going to do is select all these returns for GE. And when I'm done, it automatically puts them in there. Now I've got to click into the input X range, and I'm going to do all the returns for the S&P 500 minus the risk-free rate. So really the risk premium. And I'm going to do it to a new worksheet. That's fine. I'm going to hit OK. Now, this is a little small, so I'm going to make it bigger for you. First thing you do is go through here and widen these columns out, because for some reason this thing comes out compacted and it's really hard to read these long numbers. And so we'll just go ahead and do that. Okay, so now let's take a look at our numbers here. First of all, R squared is basically it's a measure of how well one piece of data explains another. In this case, how well does the market return explain GE's return? And the R squared here is 0.60. That means that 60% of the variance in General Electric can be explained by the variance in the market. Well, that's pretty good. Now in engineering we would have made fun of an R squared this low. We always wanted 0.95 or 0.96. But in social sciences, which finance is a social science, we end up with much lower R squareds. In fact, I had papers published with R squares below 10%, and they're in good journals too. So this is actually really great for finance type regression. Okay, now we're going to go down here and we've got intercept. So this is the y-intercept, but we said there wasn't going to be a y-intercept. So this thing should be really close to 0, and it is. Now first of all, don't be freaked out by the E05. It's E minus 05. All that means is the number in front of that multiplied by 10 to the negative 5th power. And so all we do is move the decimal point over by the number of by that number of the exponent. And so we wind up with minus 0.00007 and some change. In other words, really close to 0. So that's exactly what we wanted. And we can see over here t-stat, hopefully you remember from statistics, a t-stat that low is not significant. This thing's not significantly different from 0. Now, the other thing that we're interested in is the slope on x variable 1. That coefficient is beta. And for GE, it's showing to be around 0.894. And that matches up really well with some of the historical betas for GE that are given in your textbook. And so we've really done some good work here. It didn't take that much effort, and hopefully in the future you will know how to use Excel for linear regression.